Playing with Pis at school is all well and good, but it's when you have your own device at home, under your control and outside the constraints of the council firewall, you can have much more functionality and gain a greater understanding of how things operate. In this video, we're going to show you how to put your Pi on the internet so that you can access it from anywhere in the world. For this example, we're going to use a typical setup based on the Virgin Media system, as they are popular, open and fast. We may make videos for other internet providers as time allows. Using the graphics from the previous video, we can see that the Pi sits on the LAN side of the modem in your home. We show it here connected using the wired connection using the RJ45 patch lead. The modem shown here is the SuperHub 2 that has 4 Ethernet ports, each that can run at 10 megabits, 100 megabits or 1000 megabits. That's a gigabit. Unfortunately, this is too fast for the network port on the Pi, which will default to its maximum rate of 100 megabits per second. The yellow LED should be on continuously to prove the link, and the green LED flashes to show network activity. On the other side of the modem is the link wired out to the street and the Virgin WAN system that's connected to the internet. The speed of this connection is based upon the package that you've purchased and can be, currently, up to 150 megabits per second download and 12 megabits per second upload. The difference in speed is based on the understanding that you may want to receive more content from the internet than you want to send. Is this correct? Let's now have a quick look at the modem. It's referred to as a modem or router or gateway, as this little box does all of these things and more. On the LAN side of the system, it provides internet access via the 4 Ethernet ports already mentioned, as well as Wi-Fi access using 2.4 and 5 gig radio. You probably have PCs, laptops, tablets and phones already connected to your system at home. You already know that when a Pi boots, it calls out of its Ethernet port using DHCP. In this configuration, it's the modem that replies with what we call the SID response. Subnet mask, IP address, DNS and default gateway. All of this should be familiar from school, but at home, some interesting values are used with this modem. Let's take a close look into the Percy crystal ball and see if we can predict your IP address in your home. By logging in and using the ifconfig command, you will see that the following default values are sent to your Pi. The S is the subnet mask and will be
255.255.255.0.
The I is the IP address and will be any address in the range between
192.168.0.2 and 192.168.0.254.
The D is for default gateway, and that'll be
192.168.0.1.
And finally, the other D, for DNS server, will also be
192.168.0.1.
Now, how did we guess this? Well, the internet is a popular place and ran out of IP addresses many years ago. Luckily, a scheme called NAT, Network Address Translation, was devised that allowed IP address sharing. Your modem has an IP address on its WAN side. We will find out how we can see this in a moment. The NAT system can be set up to share 250 devices in your home. Now, this may sound a lot, but in future your cooker, refrigerator, heating control, burglar alarm system could also all be connected to the internet. But for the moment, let's just concentrate on your Pi. The modem has taken total control of your network at home. It already has prime position as the gateway between your home LAN and the Virgin WAN. It allocates all of the IP addresses and the subnet mask. It also issues its own address as the DNS or domain name server. Is it possible that this small device could hold a list of all of the names on the internet and the IP addresses they map to? Well, the answer is no. It's pretending to be a DNS server and shamming all of the knowledge of the world's addresses. Technically, it's called a DNS proxy server. It sends any request to machines on the internet that do know and then pass the results back. Sneaky. To start with, let's set it up so that the text interface and the web server on your Pi work on the web. We may not have mentioned in the past, but the text interface we have used for PuTTY uses port 22, and the web interface uses port 80. What we need to do now is program the modem so that, along with all the other usual connections, special ones are included that are directed to and from the Pi. The modem is controlled by its own web interface, so enter http://192.168.0.1. The controls are password protected. Once in, click on this Device Connection Status button and wind to the bottom of the screen. Here is the value labelled WAN IP. This is the real address of your modem as seen from the internet. Note this for future use. The process of port forwarding is the method of mapping your external WAN values to the Pi sitting on your LAN. The text interface we've been using to access the Pi uses port 22, and standard web access uses port 80. To set up port forward, select the Advanced Settings and Port Forwarding. For SSH, scan the pull down and select SSH port 22 and add. Then move up to HTTP port 80 and add that too. To confirm these changes, press the Apply button. From now on, your website and text screen will be available using your IP address to everyone on the web. I hope you've chosen a good password. To test your link, contact a friend and get them to point their browser at your WAN address. If they can see a test page, all is working. You could also ask them to enter your IP address into PuTTY to see if this opens a screen successfully. Everything is working if the prompt appears. Go and grab a red Pi at Home badge.